So for question number 14, it says solve the equation f of x equals to 0 to find the critical points of the given autonomous differential equation. Analyze the sign of f of x. So this is your f of x at the moment. dx dt is considered, this is your f of x. Analyze the sign of f of x to determine whether each critical point is stable or unstable or semi-stable, and construct the corresponding phase diagram for the differential equation. Solve the differential equation explicitly for xt in terms of t. Finally, use either the exact solution or a computer-generated slope field to sketch typical solution curves for the given differential equation. So we have the following problem. We have dx dt is equal to x minus 3. So we want to solve it. To solve that, we set x minus 3 equal to 0. We add 3 to both sides. We get x is equal to 3. We call it the critical point. CP stands for critical points. And then we want to know if this critical point is stable or unstable, but sometimes it could be semi-stable. And for stable, if you remember from the previous section, is when the graph is going to become like this. These are the kind of graph we get for stable. We call it a funnel. I'm sorry, for unstable. Get a funnel. And then I just want to make sure that I always get the word funnel incorrectly, because just let me see what terminology we use. When it's a stable, we get funnel, sorry. So when it's a stable, this is the shape of a funnel. They go both this way. Or when we do our testing, let's say at point 3 for x primes, this is what we get. Both arrows go toward each other, which I'm going to demonstrate at a moment. And when it's unstable, we get a spout. So this is what happens. That's how the graph is going to look like. That's a spout. This is infinity. This is positive infinity. For semi-stable, or let me just show this. This is what happens at the critical point. For semi-stable, this is what we get, or the other way. So this is the semi-stable. So we get something like this, okay? Now, we want to know whether right now this point, critical point, is a stable or semi-stable. So first we find the critical point. Then we put our critical point on the line. Then we pick a number less than 3, such as 0. If I pick 0 and substitute it here, we are picking a number x that is less than 3. And when we substitute it here, 0 minus 3, we get x prime is negative 3. We get x prime is negative 3. We get 0 minus 3 So x prime is -3, so x prime is less than 0. If x prime is less than 0, then the arrow or the curve is going this way. Then we pick a number greater than 3, such as 4, let's say. I pick 4 on this side, and I substitute 4 into x prime, or differential equation formula, and I get 1. 1 is positive, so x prime is greater than 0, so the arrow goes this way. And when the arrows go this way, we call this situation unstable. And this is called the phase diagram. So we have the phase diagram, we have the critical point, and we know that this is unstable. Then it's to solve the differential equation. So we have dx dt equals to x minus 3. We can solve this using separation of variable. I move this side to the denominator, and I move the denominator to the numerator of the other side. Or you can just say, let's multiply both sides by dt, and let's divide by x minus 3. That's a shortcut. So you get dx over x minus 3 equals to dt. Or you can say, let me multiply both sides by dt, and let me divide both sides by x minus 3. So if you do that, these are gone and these are gone, so that's what you get. Or the shortcut is multiply this numerator by this denominator and move this denominator to the top of the other side. So now we find the integral. We get natural log of x minus 3 is equal to negative t. I'm not sorry, not negative, positive t plus c. Then what we want to do is we are going to solve for x. So there's a base e. I can write this in exponential form, et plus c. Base to that exponent is equal to the argument, x minus 3. This is always positive, so that's why we drop the absolute values. And you can write this as e to the power 2, e to the power c. This is a constant, so that is why we can write it as et equals to x minus 3. Then it has given us an initial value that when t is equal to 0, we have an x sub 0. So we are going to substitute x sub 0 here. And we are going to put 0 for t, but e to the power 0 is just 1. So we get c equals to that, so that's our c. Let's substitute c back here. So we have x0 minus 3 et x minus 3. So now we have c, this is our equation. The last thing we want to do is solve for x. To solve for x, I added 3 to both sides. I get x is equal to 3 plus this term. And that is our equation. Now, remember, we have a point that is unstable. And if I want to graph this, let's say, if I want to graph this one, if I pick x sub 0 to be a number less than negative 3, so if I pick x0 is less than positive 3, I will get, so this is my positive 3 here, that is called the vertical horizontal asymptote, because we have right now we have an equation that is exponential equation. So I don't know if you remember, if you have y is equal to et plus or ex plus 1, then your horizontal asymptote is at 1. And then your graph is going to look like that. If you have y is equal to minus ex plus 1, then your graph is going to look like that. That is why we said we have a spout at the critical point, because the graph is going upward and then the graph is going downward. It all depends on x sub 0. So if x naught is less than 3, such as 0, 1, -1, all these numbers are less than 3, this value here becomes negative. So if I put 0, 0 minus 3 is -3, so I have this kind of function. In this case, we don't have 1. Our horizontal asymptote is positive 3. So if I put numbers x0 is greater than 3, such as 4, 5, 6, if I put 4, 4 minus 3 is positive, so I get this kind of graph. And if I get this kind of graph, this is what I get. So for x's x sub 0 greater than 3, we are going to have a positive coefficient for et. Positive 3 is our horizontal asymptote. This is our horizontal asymptote. We have x is equal to positive 3, and the graph is going to look like that. If I pick numbers x sub 0 is less than 3, this coefficient becomes negative. And if I have a negative e to the power x or negative e to the power t, the graph is going to go that way. So we have a spout at this critical point, and therefore that point 3 is unstable. So now we have our graph, and we have answered all the questions.